Hello and welcome to SQL Basics Training. Here we will be talking about a quick overview of SQL and the basic syntax that are commonly used. SQL is the standard language we use to communicate with databases. No matter if you're working with MySQL, SQL Server, Oracle, or even Access, the core idea stays the same. SQL lets us talk to the data. At a high level, SQL helps us do two things: access data and manipulate data. For example, with a simple SQL statement, we can ask the database, "Show me all companies that are not from the USA." And instantly, the database returns only the rows that match that condition. That's the power of SQL, getting exactly what you need from large datasets. So what exactly is SQL? Hello, Edsley Hall. And exactly what you need from large datasets. It stands for Structured Query Language, and it's an industry standard defined by NSI. That means once you learn SQL, you can use it across almost any database system. What can SQL do for us? It allows us to retrieve data, add new records, update existing ones, or remove data we no longer need. Beyond that, SQL also lets us design databases, creating tables, views, and stored procedures, and even control who can access what data. Moving on to RDBMS. RDBMS stands for Relational Database Management System, and this is the foundation of SQL. All modern databases, like SQL Server, Oracle, MySQL, DB2, and even Microsoft Access, are built on this concept. In an RDBMS, data is stored in tables. Think of a table like a spreadsheet. Each table focuses on a specific type of data, such as customers, orders, or employees. Tables are made up of rows and columns. Each row represents a single record, for example, one person. Each column represents an attribute, like name, address, or city. If we look at the sample persons table, each row is one individual, and the columns describe their details. This structure is what makes relational databases easy to understand and easy to query. Now, how do we work with these tables? We use SQL statements. Almost every action we perform in a database, viewing data, adding records, or modifying data, is done through an SQL statement. For example, with a simple select statement, we can retrieve all records from a table in one command. A couple of important things to remember about SQL is not case-sensitive, so writing select or select works the same. And depending on the database system, you may or may not need a semicolon at the end of your statement. Some databases require it, especially when running multiple commands at once. Now let's break SQL into two main parts, DML and DDL. First is DML, or Data Manipulation Language. This is the part of SQL we use to work with the data itself. Whenever we read data, add new records, update existing ones, or delete data, we're using DML. For example, select is used to retrieve data, insert adds new records, update modifies existing data, and delete removes data. Next is DDL, or Data Definition Language. This focuses on the structure of the database. Instead of working with the data, DDL controls how the database and tables are built. With DDL, we can create databases and tables, change their structure, add indexes for faster searching, or completely remove tables when they're no longer needed. So the difference is simple. DML works inside the tables, while DDL defines and manages the tables themselves. Now let's talk about the most commonly used SQL command, select. The select statement is used to fetch data from a database, and the output is what we call a results set. You can either select specific columns, or you can select everything using an asterisk. And just as a reminder, SQL is not case-sensitive. Select and select behave the same. Another commonly used is select. This simply means show me everything, all columns and all rows from a table. It's useful for exploring data, especially when you're not yet familiar with the table. Next is select distinct. This is used when you want unique values only. For example, if a column has repeated entries, distinct removes duplicates so you can see each value just once. Then we use the where clause. Where lets us filter data, so we only return rows that meet specific conditions instead of the entire table. When filtering text fields, we use quotes. For example, if we're searching for a country name or a customer name, the value must be wrapped in single quotes so SQL knows it's text, not a column or number. Finally, we have operators in the where clause. These include comparison operators like equals, not equals, greater than, and less than, as well as logical operators like and, or again, and not. These operators let us build precise conditions and narrow down exactly the data we want. Next, let's look at logical operators. The and operator is used when all conditions must be true. It narrows down the results by making the filter more specific. The or operator works differently. It returns results when any one of the conditions is true, so it gives a broader set of data. We can also combine and or together. This allows us to build more complex filters, especially when we group conditions to control how SQL evaluates them. It gives us flexibility to ask more realistic business questions. Once we have filtered the data, we often want to sort it. That's where order by comes in. It sorts the result set, usually in ascending order by default. If we want the reverse order, we use order by desc, which sorts the data in descending order, commonly used for latest dates, highest values, or top results. Finally, insert into. While select is used to read data, insert into is used to add new records into a table. This is how new data enters the database. Here there are two ways of using insert into. The first one is you add values on all available columns. Note that the order of values inserted is aligned to the order of columns in which the table is created. Another one is you can add only on specified columns by identifying the column names, then values. Next is update. Update is used to modify existing data in a table. A quick warning here, always be careful when using update. If you forget the where clause, you could accidentally update every row in the table. So it's a best practice to first run a select to see what rows will be affected before running an update. Next is delete. Delete removes records from a table, and just like update, it should almost always be used with a where clause. Without it, you risk deleting all the data in the table. Finally, if you really want to delete all data from the table, we can use delete from table_name.